Okay, so now we're on the very last section of the term. We're going to be looking at nonparametric statistics, and these are some methods we're going to use when parametric tests we do not meet the criteria for. So far in chapters 6 and 7 and 8 and 11, we've been looking at parametric tests. These tests have fairly strict requirements about the nature and the shape of the data. Usually, the data needs to be normally distributed, or at least we have to have at least very large sample sizes so that the central limit theorem assumptions take place and the populations become normally distributed. This is not always possible. Often we do not meet the requirements for doing a t-test or the ANOVA test. So we need to figure out some procedures to use when these assumptions don't hold. Now, if you use parametric tests, such as a t-test or an ANOVA test, when the assumptions are not met, your results, even though Minitab will give you results, will not be valid results. So we can use nonparametric tests. These are called nonparametric tests because they do not test parameters such as mu, the population mean, or sigma, the standard deviation, or p, the population proportion, and they do not require normality assumptions. So some of the advantages of nonparametric tests is they can be applied to many situations when the population we're looking at does not meet normality. And it can also be applied to categorical or qualitative data, where most of our parametric tests we needed to have quantitative data. The computations are simpler, which makes them easier to understand and to apply, and the effects of outliers are less in these nonparametric tests. Some of the disadvantages are, though, it tends to waste information. We often lose the actual numbers, and we'll be looking at qualities of the numbers, but not the actual values themselves. They're also not as efficient as a parametric test. If you know the conditions are met for a parametric test, you should use them. We also need larger sample sizes in order to reject a null hypothesis. And if the outliers are important to your study, nonparametric tests often do not take them into consideration or do not let them have the same weight that they do in a parametric test. Now we have several types of nonparametric tests. If we were looking at one sample test, like we did in chapters 6 and 7, we were looking at parametric tests, and we did either a one sample z-test, a one sample proportion test, or a one sample t-test. Now in the nonparametric versions of this, since we're not testing parameters, there is no difference between testing means or testing proportions or even testing standard deviations. We won't be testing any parameters, and we will be looking at either the sign test or the Wilcoxon signed rank test. Minitab will do both of them for us. If we have a choice, we should use the Wilcoxon signed rank test. By the end of this lecture, we'll be discussing why the Wilcoxon signed rank test is a more powerful test than the sign test, but we do want to go over the sign test. If we're dealing with matched pair data, then if we were doing a parametric test, we'd be doing a paired t-test. In the nonparametric test, we'll be doing a sign test or a Wilcoxon signed rank test. So we'll be using the same nonparametric test whether we're dealing with one sample or matched pair data. If we're dealing with two independent samples, then the parametric version would either be a two-sample t-test or a two-sample z-test. Remember, the two-sample z-test is so rare we didn't even really cover it with Minitab. We just dealt with a two-sample t-test. But the nonparametric versions of this will either be the Wilcoxon rank sum test. This test is covered in great detail in the lecture notes and in your Triola textbook. Mann-Whitney test is equivalent to the Wilcoxon rank sum test, and Minitab does the Mann-Whitney test. So when we start doing Minitab, we won't be using the Wilcoxon-Rank sum test. We'll be doing the equivalent Mann-Whitney test. If we're dealing with more than 2 independent samples, then remember the parametric version that we learned in chapter 11 was the ANOVA test, and the nonparametric version is known as the Kruskal-Wallis test, and Minitab will do the Kruskal-Wallis test for us. When we were looking at correlation, when we were looking at the relationship between some paired data, and we looked at, for the parametric version, we looked at linear correlation in chapter 9. The non-parametric version is known as rank correlation test. We're really not going to cover it in this test, but you can read about it in your textbook. You can also read about it in the lecture notes and in the Minitab lab book, but we're going to not include that in this course. So that's the end of a general overview of non-parametric statistics. We will be continuing on with the next lecture, looking at matched pairs data and the one sample data.